Nuclear warheads are very resistant to physical damage, but are very difficult to harden against extreme neutron flux. Energy distribution of weapons standard enhanced blast 50%, 40% thermal energy 35%, 25% instant radiation 5%, 30% residual radiation 10%, 5%. ERWs were two-stage thermonucleus with all non-essential uranium removed to minimize fission yield. Fusion provided P neutrons. Developed in the 1950s, they were first deployed in the 1970s by US forces in Europe. The last ones were retired in the 1990s. A neutron bomb is only feasible if the yield is sufficiently high that efficient fusion stage ignition is possible, and if the yield is low enough that the case thickness will not absorb too many neutrons. This means that neutron bombs have a yield range of 110 kilotons, with fission proportion varying from 50% at 1 kiloton to 25% at 10 kilotons, all of which comes from primary stage. The neutron output per kiloton is then 10-15 times greater than for a pure fission implosion weapon or for a strategic warhead like AW-87 or W-88. 68. Weapon Design Laboratories. All the nuclear weapon design innovations discussed in this article originated from the following three labs in the manner described. Other nuclear weapon design labs in other countries duplicated those design innovations independently, reverse engineered them from fallout analysis, or acquired them by espionage. 69. Lawrence Berkeley. The first systematic exploration of nuclear weapon design concepts took place in mid-1942 at the University of California, Berkeley. Important early discoveries had been made at the adjacent Lawrence Berkeley Laboratory, such as the 1940 cyclotron made production and isolation of plutonium. A Berkeley professor, J. Robert Oppenheimer, had just been hired to run the nation's secret bomb design effort. His first act was to convene the 1942 summer conference. By the time he moved his operation to the new secret town of Los Alamos, New Mexico, in the spring of 1943, the accumulated wisdom on nuclear weapon design consisted of 5 lectures by Berkeley professor Robert Server, transcribed and distributed as a classified but now fully declassified and widely available online as a PDF, Los Alamos Primer. 70. The primer addressed fission energy, neutron production and capture, nuclear chain reactions, critical mass, tampers, pre-detonation, and 3 methods of assembling a bomb: gun assembly, implosion, and autocatalytic methods, the one approach that turned out to be a dead end. Los Alamos. At Los Alamos, it was found in April 1944 by Emilio Segura that the proposed thin man gun assembly type bomb would not work for plutonium because of pre-detonation problems caused by Pu-240 impurities. So Fat Man, the implosion type bomb, was given high priority as the only option for plutonium. The Berkeley discussions had generated theoretical estimates of critical mass, but nothing precise. The main wartime job at Los Alamos was the experimental determination of critical mass, which had to wait until sufficient amounts of fissile material arrived from the production plants, uranium from Oak Ridge, Tennessee, and plutonium from Hanford site in Washington. In 1945, using the results of critical mass experiments, Los Alamos technicians fabricated and assembled components for 4 bombs: the Trinity Gadget, Little Boy, Fat Man, and an unused spare Fat Man. After fear, those who could, including Oppenheimer, returned to university teaching positions. Those who remained worked on levitated and hollow pits and conducted weapon effects tests such as Crossroads Able and Baker at Bikini Atoll in 1946. All of the essential ideas for incorporating fusion into nuclear weapons originated at Los Alamos between 1946 and 1952. After the Tellurium radiation implosion breakthrough of 1951, the technical implications and possibilities were fully explored, but ideas not directly relevant to making the largest possible bombs for long-range Air Force bombers were shelved. Because of Oppenheimer's initial position in the H-bomb debate, in opposition to large thermonuclear weapons, and the assumption that he still had influence over Los Alamos despite his departure, political allies of Edward Teller decided he needed his own laboratory in order to pursue H-bombs. By the time it was opened in 1952, in Livermore, California, Los Alamos had finished the job Livermore was designed to do. Lawrence Livermore. With its original mission no longer available, the Livermore lab tried radical new designs that failed. Its first 3 nuclear tests were fizzles. In 1953, 2 single-stage fission devices with uranium hydride pits, and in 1954, a 2-stage thermonuclear device in which the secondary heated up prematurely, too fast for radiation implosion to work properly. Shifting gears, Livermore settled for taking ideas Los Alamos had shelved and developing them for the Army and Navy. This led Livermore to specialize in small-diameter tactical weapons, particularly ones using 2-point implosion systems, such as the Swan. Small-diameter tactical weapons became primaries for small-diameter secondaries. Around 1960, when the superpower arms race became a ballistic missile race, Livermore warheads were more useful than the large, heavy Los Alamos warheads. Los Alamos warheads were used on first intermediate-range ballistic missiles, IRBMs, but smaller Livermore warheads were used on the first intercontinental ballistic missiles, ICBMs, and submarine-launched ballistic missiles, SLBMs, as well as on first multiple warhead systems on such missiles. 71, in 1957 and 1958. Both labs built and tested as many designs as possible, in anticipation that a planned 1958 test ban might become permanent. By the time testing resumed in 1961, the 2 labs had become duplicates of each other, and design jobs were assigned more on workload considerations than lab specialty. Some designs are horse-traded. For example, the W-38 warhead for the Titan I missile started out as a Livermore project, was given to Los Alamos when it became the Atlas missile warhead, and in 1959 was given back to Livermore, in trade for the W-54 Davy Crockett warhead, which went from Livermore to Los Alamos. Warhead designs after 1960 took on the character of model changes, with every new missile getting a new warhead for marketing reasons.
Yes, we have to stop because the camcorder is out of power. It's 90 minutes, so we have to charging. I think I will cook some hot food. So now it's dark, so let's close the curtains. Yes, I will charge the camcorder, then I will start to cook some hot food. But I'll do that in my language, Dennis. So let's do that. Put some light on. Now I have sausages from yesterday night and some potatoes, brown gravy. But I need to go to the restroom, so I will charge the camcorder. then I will read